Sometimes you're given the equation in the form y equals mx plus b, and you want to sketch it or draw it on a graph. So what you want to do is we're going to do a technique called quick graphing. That's a way to take the equation and relatively quickly make a graph out of it. Let's say the equation we want to graph is y equals 5/3 x minus 2. So that's the equation we want to graph here. And what we notice, of course, is that this is the b part. That's the b part. And this over here is the slope. We'll get back to the slope in a second. We're going to start with the b. So the b, which is the y-intercept, is at -2. So we're going to quickly start off by making a point at -2. Now we're going to turn to the slope. So the slope is 5/3. So we remember that the slope is the rise over the run, which in this case is 5/3. So what that tells us is that the rise is 5 and the run is 3. So what we're going to do is we're going to make another point. We're going to start at our y-intercept and we're going to make another point. So we're going to run 3, 1, 2, 3. You shouldn't put a point here. Sometimes I put like a little dot just to locate myself, but you don't want to put an actual point because that's not on the graph. Then rise 5, 1, 2, 3, 4, 5. And there we go. Then from that point, we're going to do it again. Run 1, 2, 3, rise 1, 2, 3, 4, 5. And there's another point. Then what we do is we could take a handy dandy ruler. Hopefully yours is better. And we're going to make a line. But you're going to do a better job than me, because I don't have my ruler. And there we go. That's the graph of y equals 5/3 x minus 2. Let's do that again. So this time we'll do y equals -2x plus 3. So that's our b. And that's our m. So we have our b, we have our m. So let's do it. So first we're going to, as I said, we're going to start with the b. That's usually pretty easy. So we start off over there. Now for the slope, we have to do some figuring. So the figurings are going to be, so slope is rise over run. Now there's only one number here. It's -2 and there's a blank. So in that case, if you don't see anything, there is something, it's an invisible 1. So the slope in this case is -2 over 1, which means the rise, so let's go to the bottom, our rise is going to be -2, and our run is going to be 1. Starting at the red point, always starting at the red point, we're going to rise 1, 2, and run 1, and there's a point. Rise down 2, there's a point. Rise, run, rise down 2, run, rise down 2, run. If the points are close enough, I'm going to try and go get as much out of it as I can, because the graph has to go from one end, the line has to go from one end of the graph to the grid to the other. Let's see if I can do a better job this time. Apparently not. Not terrible. I need to get myself a ruler. If you're watching this, you need to get yourself a ruler. And there's the graph. This is the graph of y equals -2x plus 3. It was quick, hence why it's called quick graphing. So y equals negative 2/3 x minus 1. Our y-intercept is negative 1. We're going to put a point there. Now, it's a little unclear where this negative is. The negative could be on the top or on the bottom. Traditionally, we put it on the top, but the truth is it doesn't actually matter. So if we put it on the top, then our rise is going to be negative 2. And our run would be 3. Or we could always say that it's on the bottom, and we could say that the rise is 2 and the run is negative 3. And both of those should work. Let's start from here. Rise is negative 2, run is 3. Rise is negative 2, run is 3. There's a point. Rise is negative 2, run is 3. There's a point. Rise is negative 2, run is 3. There's a point. We could also, and the thing is, we could always go backwards. We could always, and this is true, we'll see that more in the next example, often we have to switch both of them. So we could always make negatives positives and positive negative. So in this case, we could also go backwards. So essentially, we could run backwards 3, 1, 2, 3. In this case, we'd be going up 2. Backwards 3, up 2. Backwards 3, up 2. And we have enough points here for our line. Try to line them all up. There we go. Ah, look at that. That's a beautiful line. So that's the line, y equals negative 2/3 x minus 1. And it's going down, which is nice because it's a negative slope, so it makes us happy. I haven't been marking it down, but just in case, I'm going to remind you that this is y, and that's x. So let's do y equals 4/5 x plus 8. And we're going to run into a problem here. So the y-intercept is 8, so we're going to start off over there. And we know from, and this is the slope, so we know from the slope that I'll do it down here, no, I'll do it over there, that the rise is 4 and the run is 3. So if I run 3, 1, 2, 3, and then rise 4, 1, 2, 3, and I'm off over in I'm off the graph in the weird zone. And that's not so great. I don't want to put my point over there. So we're going to have to go backwards, because going forward is not going to work very well, because our point is off the graph. So if we go backwards, what we do is we switch it. So if we run backwards, if we run negative 3 instead of positive 3, instead of rising 4, we're going to rise negative 4. So we run 3 backwards, 1, 2, 3, rise 1, 2, 3, 4, and there's a point. And we can do it again, 1, 2, 3 backwards, 1, 2, 3, 4. There's a point. 1, 2, 3 backwards, 1, 2, 3, 4. There we go. And line up our points. And notice I stop at the end of the graph. I don't go to where my hypothetical weird point was over there. And that's the graph of y equals 4/5 x plus 8.